Hello and welcome back to the Winning at Blackjack series. Today we are on episode 8 and we shall be going through some basic strategy deviations based on the true count. Very briefly, some moves in Blackjack we will change if we have a certain true count. For example, if we have a higher true count, we may want to stand on a 12 rather than hit when the dealer has a lower card. So, the way we're going to do this is with a new list of the basic strategy, with deviations included. First, take the normal set, the total of our cards, and the dealer's card value, then colon the action we'll take. Now we're going to change it. All of our values will have a third value in the brackets. This value will either be the true count we switch to when there's a deviation, or N, meaning we don't have a change in any true count. Then we will have the action before the true count, slash the action after the true count. So, to make sure this makes sense, let's take an example. 12, there's a value, with a dealer free value card. Now, if we have a true count 2 or higher, we want to stand, otherwise we will hit. This is represented by 12, 3 as expected, then the true count we flip at 2, then the action we will hit if at below that true count, then slash stand, and that's if we are greater or equal to that true count. Now we will do that for all values. The chart I'm going to get this off is the Blackjack Apprenticeship Deviations chart. You can get this yourself by heading to Blackjack Apprenticeship and signing up to their newsletter, then you can get access. Due to the size of these lists and time to go through them, I will paste the lists into a GitHub for you guys to copy. We will need this for our hard strategy in a list called True Hard Strategy, soft in the list True Soft Strategy, and finally splitting with the list True Split Strategy. Now that makes sense, we're going to use these lists to change what action our simulation will pick for our player. So let's head down to our player function and go down to edit our action picker. So first we need to grab our true count. Do this by just doing true count equals true count cards left like before. Now we will need to check the keys for each true count. So we will first indent our whole area so we can add a for loop. This for loop will introduce a new variable called ranges. This will serve as a variable to find the correct value in key. This will start by going through n, as this is most common, so might as well try and catch it first to speed up the program. Then it goes from all the numbers possible in our deviations, and that's from -2 to 6. Now we need to change the key to include this variable like inside the lists. To do this, we just by adding ranges to the end of the bracket. So now we will get the action from the new list by changing the list we are checking to the true ones and breaking the for loop if we find it, just to make the program a little bit faster. No point checking the next values if we have found the true count value that matches. So perfect. Now it will get our action correctly, but what is the deviation? Then we have the slash in the middle. Well, let's resolve that now. If the key 2 is a strategy deviation, then we will not expect the action to be N or nothing. Nothing means we have a value of cards so low that we will just hit, and N of course means it doesn't have a deviation. However, if it is a deviation, then we go into this if statement and make a list that is made by splitting action variable by the slash. So our first element in the choice list will be our action if we are below that true count, and the next element is the action we are on or above that true count. So we just need to see if we are above or below the true count. Simply, if true count is bigger than key 2, then set action to choice 1, else then we set action to choice 0. Great. Deviations are done for soft and hard strategy, so we just need to do it for the split strategy. which will be very similar. So heading up to the split algorithm, we will once again add a for loop for ranges, this time ranging from n, 4, 5, 6, since these are the only values that we actually use in the true split strategy. Then, just like last time, we add our ranges to the key at the end of the bracket. Now, removing the old method, we will place in try and except block, then, just like before, send in our key to the new true split strategy list. When we get our result, if we are in a deviation, as in ranges isn't n, then we will again split into a choice list. Then, if our true count is higher than the ranges, we pick choice 1, else choice 0. Then in the except block is a key error. If the key does not match anything in the list, this case we will just go to the next for loop value. That is all the logic we need. So now let's run it and really see the difference that these deviations can make. After 1 million runs, we get all the way up to $400,000 from $100,000, which is great. Similar wins and losses as before, as we can expect, but we can see we won on average 2.96% back a hand in this particular run, which is better than the previous video. So hopefully it has worked and we haven't just got lucky. Our simulation is complete now. You can run it, place in different values of money and different ways of increasing your bet based on the true count. So now what comes next for this series? Well, we are going to derive our own basic strategy using a lot of simulations, which shows in real life how you and people before have got to these basic strategies to maximise their chances of winning. So, I hope you're ready for that video, and if you enjoyed this video and or learned something, please like and subscribe to help support the channel, and I hope to see you in the next video.